Kia ora everyone, my name's Jim. Thank you for having me here at Wellrailed. Naming things is indeed hard. It's like when you call something new, you just know it's going to be in production forever. A little bit about me. Several things before my current role as a security consultant. Worked at a bunch of different places. I ran my own business for a long time. This was the business I ran. It was a really bad time and also the best time. I toured a bunch of bands in the early 2000s from around the world. Probably about 85 at last count. So if you saw an indie act between 2007 and 2014, it was probably one of mine. I am a senior security consultant at PaperKite Consulting. I'm a former software developer, which makes me reasonably well, suited to talk to fellow developers. Sorry if you've ever had to use anything I've made, because I wasn't the world's greatest developer. I help organise ISEG, which is the Information Security Interest Group, last Thursday of every month. Bo Wood is talking this month about some ransomware they have built in Rust. So if you would like to go and see how ransomware is built, Thursday at the Thistle. I am an active security researcher. My colleague Thomas, who's just there, and I are speaking at DEF CON in about 2 weeks. We've done some very specific research into some Microsoft things, given them a bit of a kicking, and we're going to go drop a bunch of O-days. So we found 4 bugs in Microsoft. 3 have been awarded bounties and CVEs. One they said is, yes, it's a bug, but it's not a good bug. Thank you, Microsoft. We found a bunch of CVEs in OWASP Math Type, which was in Blackboard and Moodle. Thomas and I found a bunch of CVEs in Kramer Products, which is this little audio-visual conferencing thing. Unauthenticated file read, SQLI or Squealy, as I once called it. Again, naming things, really hard. And unauthenticated file upload resulting in remote code execution. That was a delight to find. I am a frequent flyer with CERT, which is the Cybersecurity Emergency Response Team. The real MVP of cybersecurity in Aotearoa. And related to CERT, please don't ask me about council software. It turns out I can't use any council infrastructure without having to go to CERT. Anyway, so OWASP. It is the Open Worldwide Application Security Project. Hands up if you've heard of OWASP. Okay, that's good. That's a good number of people. That's really, really good. It's an online community. It has a lot of free and open source tools, methodologies, documentation, and technologies. There's about 250 chapters worldwide. There is an Auckland one. There is a OWASP Day in Auckland later on this year. It's actually 2 days. There'll be some great talks. There'll be lots of training, AppSec stuff for anyone who's interested in application security. And everyone knows they have a top 10. I'm not going to read all of these out because we are going to go through them, but everyone knows they have a top 10. It was recently redone in 2021, and before that it was 2017 was the last time they'd reorganized it. And the question is, why should I care? Well, because there's no such thing as a solved problem in cybersecurity. About 3 hours ago, Thomas and I were cracking a database using some SQL injection, which is a supposedly solved problem. So it's not really. So when I started as a pen tester, I was told that I could look for Squealy, as I mistakenly called it, and it will haunt me forever. I was told that it was a solved problem and that I could look for it, but I might not find it. I found it on my 3rd job, and I've been finding it at a rate of about once a month ever since. How often do you find it, Thomas?
About the same.
So
maybe every couple of weeks. Yeah,
no such thing as a solved problem. And I know Rails has Active Record, which has solved that particular problem, right? Has anyone run Brakeman over their code base lately? Yeah, cool. So anyway, the first one in the OWASP Top 10 is broken access control, which is one of my favorites. This is something I have found a lot in Ruby and Rails applications. A lot of people will use Devise and other nice gems to sort of deal with that kind of stuff. Not always successful. Sometimes things will slip through the cracks. Ruby and Rails, you like to use integers to kind of do things, so quite often insecure direct object references will make an appearance. Basically what this means is incrementing an integer. So you might have a user ID equals 244. If you increment that, what happens? Sometimes it's as simple as that. Sometimes it can be tampering with an authentication mechanism, such as a JSON Web Token. algnone is a really good one. Has anyone come across that before? Yeah, that's a really good signing algorithm that's used And it was, I think, yeah, it's been used out in the wild, and I find it from time to time. It also means being able to browse admin pages as a low privilege user, that's broken access control, or able to update data or retrieve data of another user. And I'm looking at you, Optus. Did anyone remember the Optus data breach from about 2 years ago? There are lots of lovely integers involved. Yeah, James there works at the Privacy Office of the Privacy Commissioner, so
Try and keep an eye on data breaches.
for some weird reason.
Sorry.
Yeah. So a former colleague of mine wanted to rent a car. And they signed up, they submitted their driver's license, and they were emailed a link to their document. And they got emailed a link to an S3 bucket. So what do you think a hacker does when they see a juicy integer like that? You just add increment, woo! Thank you, Nick. Yeah, nice integer. It would be a shame if someone was to increment it. So they saw someone else's driver's license, and they had to go to cert, and that was a great start to the holiday. So yeah, I don't know. Oh, disclaimer, don't do crimes. If you see an integer, I don't know, you can increment it if you want. I'm not a cop. But if you do, you have to be prepared to tell someone, and we'll talk a little bit about that later. Cert is the place to go. If you see something, say something. They will help you out with that. So in the wild, again, I have found another, I have a million of these stories, by the way, you can ask me afterwards. I came across a client doing a large amount of document processing. Document processing to a pen tester is a glorious and wonderful attack surface. It's a really fun thing to do. So I found a tool, I found a document using a tool called GAL, which stands for Get All URLs. It's a tool built in Python that searches like the Wayback Machine and stuff. We'll talk about that a little later. The documents were GUIDs. Everyone knows what a GUID is. Nice, unguessable, not easily incrementable, which was great. I clicked on the document and then it asked me for a PIN, and I went, a security control. Oh. And then it said, if you don't have a PIN, what's your email? And I said, here's my email. And then it emailed me a PIN. And so that was great. So I entered my PIN, and then my little session cookie was generated. And then I found an API endpoint that took integers. We all know what to do with integers. And it took my little session cookie, and it had no access control. And there were roughly 500,000 documents going back 5 years. So this was a great thing to find, and this is one of those, I've got to get on the blog. I called the client, politely explained to them. So the first time this happened, because I tested this client twice, this was the first time, and I'm not sure whether they had a privacy officer or anyone, but I think by the time that we retested them, there was nothing left on the server. They just dumped everything off, they got rid of it. And yeah, I do a great talk about, I think it's a great talk, about data breaches and how they happen. And one of the things I cover there is principle number 5 of the Privacy Act, which is what are you storing, why are you keeping it, and how long are you keeping it for? There's various protections, and James over there can talk to you about safe things to do with data or not. Sorry, James. But this is your wheelhouse, not mine. Anyway, so yeah, that was really fun to find. So, I like to think that I stopped the data breach. I don't know. Yeah, so there are mitigations. Deny by default is a really good one, obviously except for public resources. Implement access control and use it everywhere. Rate limit API calls. How many of you have alerting in your web applications for 403s and 401s? We have one person at the back. Well done, you. So that's a big thing to think about. If you're seeing a lot of 403s or 401s, it's probably a sign that someone is trying to see something or access something that they shouldn't, and you might want to do something about that. Look at the way you handle sessions and use GUIDs instead of integers. That's a really good starting point. Even though it may be possible to leak a GUID at some point, it will make it significantly harder for someone rather than just doing what you learned when you were 5 years old and adding numbers together. Number 2, cryptographic failures. Sounds ominous. Some brief definitions before we get too far into cryptography. It is the act of communicating securely, and it covers things like techniques for secure communication. It also means constructing or analyzing protocols to prevent third parties or the public from reading private messages. Thanks to a lot of hard work from a lot of people, it's now almost everywhere. It's been around for thousands of years. It's one of the things that we can say in technology has been around for a long time. This was previously known as sensitive data exposure in the 2017 OWASP, but the root causes are often cryptographic in nature, so I think they sort of realized that and kind of reassessed. So as we all know, there are lots of sensible things to do with cryptography. Encrypting data is my favorite. Let's Encrypt has made it really, really easy to do that, easy and free. You can also self-sign certificates and make people click through warnings, but Let's Encrypt is better. And anyone who's ever done any person-in-the-middle attacks on an internal network will know that there are some not-so-sensible things happening that don't use cryptography, such as FTP, SMTP, and Telnet. Anyone who's done impersonation attacks in an internal network will know that there is a lot of unencrypted traffic flying around at any given point. There are common attack types, such as padding oracle attacks, which are fun to exploit, which is cryptographic error messages will tell you whether something is correct or not. Sometimes failures can be as simple as checking in a crypto key into Git or other key management failures. That's really, really common. Sometimes there's also not enough randomness. Does anyone know how Cloudflare generates entropy? So Cloudflare have a wall of lava lamps that they have a camera trained at, and they use I think it's like 100 or so lava lamps to generate entropy for their secure random functions. Now, I'm not saying that we're Cloudflare, but, have a look at how you're generating random numbers. That's always a fun thing. So, padding oracles. So when you encrypt things, block ciphers only encrypt in certain sizes. Not all data is created equal, so it means that sometimes you'll need to pad things out. And a padding oracle is present if an error message leaks the specific condition for valid or invalid data. So what this means is it can be used to encrypt things such as an encryption key. Doesn't happen so much in Ruby and Rails, but .NET has had some doozies within this. Lots of tools exist. They will send several thousand requests, and they will eventually get there and unearth the data. It's very exciting. And yeah, Thomas could probably talk to you afterwards about cryptography because that's your passion. So yeah, the mitigation is really simple, and this kind of falls back to the privacy stuff as well. If you don't need it, don't store it. That's probably the simplest way. Encrypt all your data at rest and in transit. Disable caching for sensitive data as well. It's not just your browsers that cache things. Things get cached all over the show. Every layer of the stack will try and cache something. Also classify the data that your application is using against the laws, requirements, and business needs. So yeah, have a think about it. And make sure you're using the cloud, the lava lamp wall or a secure random function if you can't be bothered. Yeah. AO3 injection. This is one of my personal favorites. Server-side request forgery is my number one, but that's at number 10. So. Wherever there is data accepted from the client, there is the possibility of an injection attack. So lots of different types of injections. My favorite is Squealy. Cross-site scripting is also very, very good. LDAP, Lightweight Directory Access Protocol. The word lightweight is doing a lot of heavy lifting for those who understand that protocol. Command injection. So when I was casting around for ideas from this talk, I messaged a Ruby developer friend of mine, and I asked him what some of the more egregious Ruby and Rails things he had seen was, and he said, open params path or URL. So this does happen in Ruby as well. Expression language injection, that's very much a Java thing, but also template injection, not so much a thing these days with ERB. There's a lot of fail-safes you have to unpick to make these things vulnerable. It does happen, but the defaults are generally pretty secure. And yeah, sometimes you can run Ruby commands like system within templates. So client data, it should be inherently untrusted. So these attacks will happen when there's no validation, filtering, or sanitizing kind of happening. And when unsanitized data is injected into queries and concatenated, that's when injection attacks. And on the client, when you have unfiltered or unescaped content coming back to the browser, little angle brackets, that sort of stuff. Reporting engines are my favorite place. Every time I reorder some data, I just have a look in the query string. Yeah, and there's multiple instances of SQL being constructed in JavaScript. Don't ask me how that happened. It just happens occasionally. There's some places I've had to go to cert about that are constructing SQL in JavaScript with the predictable results that you can imagine. So Rails and Ruby, it's more common than you would think. That's why railssqli.org exists. Has anyone seen that website before? Yeah, I recommend going to have a look at it. Active Records, really good. It's a great relational mapper. But there are a lot of things that were not intended to be called with unsafe input. So it will give you enough, you can foot gun yourself with it. quite significantly if you're not careful. So yeah, calculation methods such as average, calculate, count, maximum, minimum, all can take raw SQL, along with all these great methods. So yeah, just be very careful about what you're passing to them. And up until Rails 5, order and pluck were vulnerable. Order was my favorite, because if we look on this previous one here, fakeapp.com, if I saw sort equals DSC, all in caps like that, is a good idea of where that might end up. And so you'd usually find order by injection, looking at parameters like that, and that's, yeah, there's a bunch of Rails apps that I've found injection like that. A lot of people do sensible things and put them into enums. Some people just pass it straight into the order query. I've also seen a lot of obfuscation with GraphQL, which Brakeman won't pick up because it's not taking it straight from params. It'll go to the GraphQL layer and then go through the data layer. So here's an example. This is pretty low hanging. Who knows what a Google Doc is? Yeah, the bug banny guy over there knows the Google Docs. It's basically a way of finding a specific string within a website. And so this is a really good one for SQL injection. In URL, product-list.php, ID equals. And then so I went to this site and I put in a single quote, and then I didn't do anything else because I'm not a criminal. I just took a screenshot and walked away. But yeah, very easy to find these sorts of things. As you can see from the MySQL MariaDB server, it is basically saying, you've got a SQL error. Yeah, I don't know how that's going for them. Probably not great. Yeah. Oh, this was a good one. I added this specifically because it is a Ruby one. My colleague Michael, former colleague, very, very good hacker. He found a CVE in Refinery CMS. Has anyone come across this? I need to talk to you after this because you know everything. Yeah, so the root cause was the Dragonfly library for handling images. Shell words was used to block most special characters. Yay, which was really good. But shell split was used first. Space or new line characters could be used to inject arguments. Oh no. So it allowed for arbitrary arguments to be inserted into the convert command. And there's a utility within ImageMagick that can read single byte gray samples. And yeah, I'm going to show you what that looks like. So did you work on this with Michael Thomas? Yeah, you'll be able to explain it better afterwards. So basically, this is what's getting passed in. So we have the convert argument, and we're saying, Gray, just give me that file etc password, and it's base64 encoded and passed into the query string or into the URL, and then look what comes back. Yay, it's the contents of etc password. And you changed it into remote code execution, didn't you?
Yeah.
With file rate?
There was another thing that was running that, like, if you dropped a file into temp, it would restart the web server, and you could drop a file into the web room, and then it would parse it.
Yeah. I've also seen Michael do similar things where he's leveraged ImageMagick to write out to the application controller.rb and insert a backdoor. So, yeah. Michael is very, very good at this sort of stuff, which is why I wanted to include this in here. Yeah, so in order to prevent injection, well, use safe APIs and just avoid the interpreter entirely, but obviously ORMs such as Active Record, I'm saying it's pretty good. It's generally pretty good. SQL structures such as table names and column names cannot be escaped. So really common in report writing software is the client will often specify column names. So you do have to be a little bit careful. And just use limit and other controls. This is what OWASP says. I don't really agree with that. I mean, if you've got SQL injection, you've got SQL injection. Limit's not really going to help you, but yeah. Yeah. AO4. Oh, we're just whizzing through it, aren't we? This was a new category in 2021. So this relates to things like design and architectural flaws. It also includes things like password reset questions and other easily guessable evidence of identity. It also includes things like anti-bot protection, which prevents ticket scalping, and what happens if you're selling thousands of GPUs for some reason. I don't know. So the SDLC, the software development lifecycle, hugely important to sort of help protect against this. So yeah, the cultural methodology within an organization is what lends itself to secure code. One thing I've noticed is as a security consultant, we'll go in and do a pen test, and we will inevitably delay a project by 3 months while they go and fix all the things that we've found. However, if you front foot these things and build it into your workflows, you might get away with not having a bad pen test report at the end. And Nick, you'll probably be able to talk a little bit more about this. This AppSec is more your wheelhouse than mine, I would say. But yeah, enforcing conditions for proper behaviors, documenting the use cases and user stories. And also, if there's the concept of a use case, try the misuse case and write some unit tests to codify the bad things to make sure that they don't happen. And that'll get you a lot of the way there. So yeah, don't roll your own cryptography. It's a really good thing to start with. And just make sure you use secure design patterns and components. Rails is pretty good. Like, there's always an opportunity to footgun yourself, but the defaults are pretty sane. So I think you folks are fine for the most part. But use threat modeling to understand where your application-specific risks are. Because you have tools like Brakeman, which are really, really good for injection-based attacks. But Brakeman doesn't know anything about the business logic for your application. It doesn't know anything about your role-based access control or anything like that. So you will have to write unit tests as well to sort of kind of codify these misuse cases. Cool. Security misconfiguration. This was number 5. A lot of ways that things can be misconfigured. How many people have seen a Ruby application with debug mode in production? Yeah, a few people out there. No one? Okay. It does happen from time to time. Also means things like default usernames and passwords. Exposing ports and services that you probably shouldn't. Even things like having directory listing enabled. It means that in some cases it can allow for source code to be downloaded depending on the server. Also sample applications and framework. Tomcat is a favorite one for that. I think it's called /examples/calculator.jsp. People find good bugs in those things all the time. Security settings not set to secure values in the framework. I have seen several Rails applications where the cross-site request forgery tokens are just explicitly disabled for some reason. It does happen. And make sure that your application security process is robust and repeatable, which generally means automation. So a good example is the Humble S3 bucket. How many people are Azure and how many people are AWS? Mostly AWS.
GCP.
Wow. And GCP, look, you've got 74.1k buckets exposed. Yeah. So grey hat warfare, someone basically just came up with the idea to index all the public buckets they could find and, let you go and search for things like password.docx or whatever. Very, very exciting. You can also check for source code because quite often that will get deployed to a bucket as part of a deployment process. I've seen that in a non-zero number of jobs. I don't know why. So grey hat warfare is a thing. Go and have a look. Just stop short of doing actual crimes again. But yeah, it's a really fun place to look for these kind of things. So, property managers. Aren't they just a bastion of goodness in the world? And I'm sure they write the most secure code and they're amazing. So in 2020, LPM Property Management left about 30,000 images of personal information exposed. A security researcher contacted them and said, your information is exposed. And then 2 months later they said, look what we've found. We've found some exposed information, aren't we good? And didn't credit the researcher, and then they went to the media. But yeah, it's not just small companies. Netflix, Ford, Facebook, Time Warner, they've all been caught out with exposed buckets. I think it's about 2 months ago now. Microsoft had one with exposed passwords and credentials for a lot of internal services. They're a very serious company, so I'm not sure how that happened. So I've got a beef against the Microsoft Security Response Center. It's a long story. But yeah, there is some remediation for this, making sure your hardening processes are repeatable. Remove and uninstall unneeded things. Segment your architecture as well. Make sure that your network segmentation is good. And just make the process automated so you can do it again and again, and you can codify the good things in. And so you remove that kind of human error from the equation, unless you put the human error into the template that you're deploying from. Yeah. Cool. Number 6, vulnerable and outdated components. So this bit is reasonably self-explanatory. So who here knows what Dependabot is? Good number of people. So Dependabot will nag you and you'll be like, who's making these pull requests? So what Dependabot does, for those who don't know, will look through your gem file and go, that thing's got a CVE, I'm going to version bump it to the non-vulnerable thing. And it'll make a pull request to do so. Little does it know that you will be in dependency hell if you merge that pull request and you'll break production. But yeah, it's not just limited to custom code. It's things like vulnerable components. Yeah, thankfully you're not Java, so you didn't have to deal with any of log4j. Although you probably would have read about it and gone, that sounds fun and delightful, and what a way to ruin a Thanksgiving break for everyone. There are also difficult realities. I have a friend who is the sole application security engineer for a biomedical device company, and it's got about 2,000 people in it. And yeah, he basically said the devices that they install in hospitals have a lifespan of 7 to 10 years. It's incredibly hard to patch them in place as they are almost always in use. Yeah, and even the big vulnerabilities, I'm showing my age here, but Heartbleed, there are still services out there vulnerable to Heartbleed, which was a doozy from about 10 years ago. Lots of automated tools exist to help you find things. Shodan has a find all the Heartbleed button, which is really great if you want to go and see what's still out there in the wild. Not for crimes, just for like research and stuff. Yeah. So log4j was discovered in Minecraft. Players discovered they could run code on other players' systems. So at the peak, there are around 10 million attempted executions per hour, and that's just from the people with the Z-scalers and the WAFs and all the actual security controls in place that were reporting on this. I would imagine the actual number of attempted executions was a lot higher. So it came about with the insecure design of Jindy. That's how I say it out loud. I'm right on this, and the Java naming and directory interface. So log4j is a library that logs things, and if there's a Jindy reference in the log, log4j will request data from an LDAP server, and you can request a malicious Java class, which will then be downloaded and executed. And that's about as bad as it sounds. Yeah, so I don't know what the total fallout was, but a lot of people had a really, really bad Thanksgiving weekend. So the question is, what does your patch management look like? Cloud providers do some of it, but when it comes down to knowing where your security boundaries are you using a platform as a service? Are you using infrastructure as a service? Are you using software as a service? Who is responsible for what? And that's a really, really good thing to bear in mind as a software developer, who is responsible for what patching, because you don't want to be caught out by something that you thought someone else was patching on your behalf. Cool. Making sure you have a patch management process is a really good first step to the mitigation. But maybe the first step is actually knowing what you have. Asset management is a really hard problem, particularly I was talking to someone from the Wellington City Council who was a software developer there, and they said they had approximately 400 services online. How do you even begin to, they had a team of like 20 people. How do you even begin to quantify and protect that if you don't know what you have? And monitoring for things like unmaintained libraries, really, really good idea. And just try and use signed and verified packages wherever possible. But, this is hard because software always moves and grows, and it's very hard to keep pace and constantly patch things. Cool. AO7. This was previously known as broken authentication. So these sorts of weaknesses can be here if an application allows for things like credential stuffing. Has anyone come across that concept before? So if your username and password is caught up in a data breach of some kind, and someone cracks your password and you've reused that password, but no one here reuses passwords, so it's sweet. Yeah, that's credential stuffing. And I think Ticketmaster, Snowflake, those big round of breaches were all from credential stuffing. It also includes things like weak and guessable knowledge-based answers. So one of the vendors who installed a lot of ArcGIS, which is basically big mapping software beloved by councils, they have a super admin takeover flow that basically goes, what's your dream job? And you go, GIS. And it goes, cool, here is your super admin credential. And so you can then log in and upload your own bits and pieces and compromise the server. And they use the same answer across all installations. And so I tested like 5 of these different things in a row for 5 different clients. And it was just cut and paste. Yeah, it was great. It also means things like not invalidating session IDs. So if you log out of something, but then click the back button and you log back in, it means that a session ID isn't being torn down, or a session's not being torn down correctly. And similarly, exposing session identifiers in the URL. We'll talk about how nothing ever disappears from the internet and why session IDs in the URL, for caching reasons, for history reasons, not really a good idea. Yeah. Yes, credential stuffing. So when a password that is reused on a site is caught in a data breach. Yeah, so I don't think I tell this story in this one, but I'm going to tell it now. So, James, this is your favourite story. When I first started at ZX, we had what's called Steamer, which is like a password dump thing. I don't know why. Thomas, why is it called Steamer?
I have no idea. That's just been called Steamer forever.
Anyway, it's password dumps. And so, as the responsible citizen that I was like, I'm going to look up my mum's name. I'm going to look up her email address and just see what happens. She's got my brother's name as her password. And then so I was like, I'm going to look up my dad. It's the dog's name. So not only was I not the password child. Anyway, yeah. So passwords in general, as passwords, we're kind of stuck with them for the time being. There are better solutions. Hopefully everyone here has MFA turned on. So the advice used to be to rotate passwords. Yep. And then eventually it was realized that people will just add numbers. So now winter 2023, summer 2024, I was working on an external pen test, and one of my colleagues, Ethan, I think he got about 300 people with welcome 1, 2, 3, 4, 5. Because the IT team had decided to reset, their password reset script had this hard-coded, and they didn't force change password on next login. So there were 300 users, half of which had MFA, half of which didn't. We got on the VPN and were able to start moving internally. So yeah, it'll get you into a non-zero number of organizations. So again, don't do crumbs. Cool. So prevention, MFA everywhere. MFA basically works alongside passwords because a password is what you have, password is what you know, and MFA is what you have. And between those two things, you're in a much better position than just a password. Your web application might want to check against weak passwords and breach corpuses. Dropbox open sourced something to do that, although you could probably do it yourself if you really wanted to. Just making sure that your registration, account recovery, and APIs are hardened against enumeration attacks as well. Cool. Software and data integrity failures. So this was a new category for 2021. It didn't really exist before that, but with the rise of DevOps and CI/CD and all that kind of juicy fun stuff, it's a little bit more important. So it extends to things like third-party plugins, libraries, modules from untrusted sources such as content delivery networks, other untrusted sources, random repositories you found on the internet. Who's been guilty of finding a GitHub repo and being like, this does exactly the thing I want, but it's only got 2 stars. Anyone ever been in that situation? Yeah. Insecure CI/CD pipelines can often lead to unauthorized access, malicious code, or system compromise. Pulse Security have done a great series of blog posts about GitLab and about escaping the runners and escalating privileges from the intern to the admin and stealing secrets and the like. They're very, very good. Some famous examples. Anyone come across the SolarWinds Orion attack? Yep, great. Cool, so hackers compromised the supply chain, and there are around 30,000 customers who were impacted, and only 100 had to run an incident response, apparently. So, lucky. Yeah, so malicious code was injected by hackers, and it was sent out through updates. So, a not-so-famous example, has anyone ever come across typo squatting? Have you ever typed in bundle install and then typed in the wrong thing, and it's found it, and you're like, oh shit, Control-C, get out of there. Yeah. So it extends to Ruby gems. The most recent count, there are around 700 malicious packages on Ruby gems. I made a Ruby meme. I hope everyone likes it. Anyway, trying so hard. Anyway. Cool. There are ways to prevent it. Make sure your libraries and dependencies are consuming trusted repositories. Dependency checkers exist. Use them. That also extends to things like every time you put jQuery on a website from one of the CDNs, are you doing a sub-resource integrity check? If not, maybe you might want to look into that. And like I mentioned before, Pulse have done some really good work about escaping GitLab runners. Cool. A09. Almost there. Security, logging, and monitoring failures. So how do you know, as a web application developer or someone in the DevOps space, if someone's rattling your doorknobs, who's port scanning you, who's enumerating your application? Detecting and responding to breaches is pretty critical. So this can happen anytime that events aren't recorded, or log messages are unclear, or application API logs aren't monitored. They might just be going into a Slack channel that no one has access to, or they might be going into someone's email address who no longer works at the company. It also extends to things like local storage of logs. If you're just storing logs on the application server and someone has compromised the application server, no logs, no crime. So make sure that you're pushing things to other servers as well. So when I first read a variation on the statistic, which was in 2023, the average length of time to detect a breach was 204 days. I didn't really know what that meant. This would have been a couple of years before. And then I thought about it, and I was like, in December 2022, I was working on a job. We gained domain administrator from an external server. They had a server that was sitting on the perimeter. They said it was in the DMZ. It was not. So we compromised the server. We notified the client straight away, the one client contact we're dealing with, and we heavily enumerated the domain, 20 to 30,000 requests, just mapping out the internal Active Directory domain. Then in February 2023, we received an email from another team in the client asking if we were pen testing in December. So yeah, it's a real thing. They were clearly getting some alerting several months after the fact. Yeah. So it took 3 months from getting domain administrator to actually getting asked about it. So in order to prevent this stuff, make sure you log your failures with enough context to know what is going on. Everyone here has probably come across Datadog and Splunk and all those kind of upstream things that consume and allow you to query logs. Make sure your logs are being logged in a way that all these tools are going to like and make it easily searchable. You don't want to be, struggling against the previous version of yourself when an event is unfolding. Making sure it's encoded well as well, so it can be passed around without breaking things. And think about integrity controls, such as an append-only database, which is a great way to, it's a database that can only be appended to, can't be deleted or dropped. Create an incident and recovery plan. How are you going to, restore from snapshots or go back to a known good state? And monitor and alert so that suspicious activities are alerted and responded to. Just having an idea. Has anyone ever opened port 80 on the public internet? Yeah, it's a time. Yeah, I advise you to just do it out of curiosity at one point and just see what happens and see how many things will rattle your doorknobs. It's illuminating. A former colleague of mine actually ended up reverse engineering some malware from, do you remember Dan's project? Yeah, he found some sort of botnet and reverse engineered the malware that was being sent out via it. So, it's fun to open port 80. Ooh, my favorite. Server-side request forgery. So, when a web application fetches a resource, which is what they do all the time, it's kind of how computers and the internet works, you can have server-side request forgery. So this generally happens when URLs aren't validated. So you have different types. You have blind SSRF, which means that you don't see the response of the network request that you've coerced a server to make, but you do see the outbound request. You have non-blind SSRF, which is a fun one, which means that you see the response of the request. And you can also use things like blind SSRF to port scan internal servers. So if you have got SSRF on an external network, you can start looking inwards with this and start port scanning IP addresses. And based on the response time, you can get an idea of what ports are open and closed internally and start moving around. So the outcome of this bug is frequently sensitive data exposure. And quite often you can mix up the URI handlers. So you can, instead of a URL being an HTTP scheme, you can just point it straight to EDZ password and get file read. Who here has used WK HTML or PDF? Do you know about the fun bugs that are in it?
I've gone into it a bit and it was terrifying, I think. You realise what it was based upon. It didn't feel like it would be remotely secure.
Yeah, and it's not. So a lot of what you do as developers is sometimes you'll have a product manager assign you a Jira task, which will be like, export this report as a PDF. And you're like, yep, sweet. I'm going to turn this HTML into a PDF. And so how these PDF generators tend to work is they will just spin up headless Chrome on a server. And when you are spinning up headless Chrome on a server, all the lovely browser controls that you get running it on a client tend to go out the window. So WK HTML to PDF in particular, there's about 10 of them that are very well known. They are a delight for a penetration tester. So in AWS, does anyone know what the AWS metadata service is? Yes, have you had a pen test report where you've... Yeah. So the AWS metadata service is accessible on 169.254, etc. And it's basically a linked local address where the running EC2 instance or something else within AWS can query things about itself, the metadata essentially. But this metadata also extends to things like secret access keys. So if you have server-side request forgery in an AWS instance where you have the metadata service enabled, you can issue credentials for the currently running EC2 instance and then start to enumerate the AWS domain and start to try and move inwards using it. Now by default, the version 2 is enabled, which requires headers to be sent with a request, which prevents things like iframes in PDF from hitting this straight away. So things are slowly moving, but you have to enable it. You have to enable version 2 to get the goodness. Cool. Prevention. Segmentation is a really good way to try and prevent SSRF. Firewall rules are really good. Make sure that you're blocking outbound as much as you can. Like anything from the client, don't trust it. If there is going to be times when you're going to have like webhooks or whatever, which are basically what we'd call an SSRF primitive. There are going to be times when you'll need to take a URL from the client and do something with it. Just be careful. And you can also have DNS rebinding attacks, which is a way of tricking DNS into quickly updating itself with a time to live of 0 seconds. So at first it can go, oh yeah, this is totally legitimate, and then it'll go, aha, here's my bad one. So but from the time you send the first DNS request to the second, it will quickly change. So there are ways to bypass fixes. Yeah, well now go hack all the things. You're about to do Juice Shop, so that's great. Lots of safe places exist. Pentester Lab, Hack the Box, Try Hack Me. And just imagine in your software development lifecycle that you are a QA looking to take the most unhappy path possible through an application. Cool, any questions? Cool. Yes, Christian.
Would it be illegal?
Without consent.
Without consent. So
Yeah.
like if you do something, that's like you should refer to a certain right?
Yeah, pretty much. If you come across something and it's like a low-hanging kind of, I've made a number bigger and I'm seeing something I shouldn't, just go to cert. I think it's just, Hervé will sort you out, one of the other fine incident responders. But yeah, occasionally you just will exist in the world and see things that are illegal. You just have to go to cert. Cool. Any other questions?
No, I got a question.
Yeah.
So you said for something as small as, if like the session isn't being invalidated when you
Yep.
go back, right? Like a local page, would you go to surf something like that?
No.
Or nothing like that?
No.
So it's not technically illegal, it's just bad design.
It's just bad design, yeah. I mean, the security.txt standard is gaining some traction, and if you see something on a website, you can go to well-known, or is it .well-known/security.txt, and that will tell you who to report something to. However, when I was at Radio New Zealand, one of the biggest issues was it's very easy to put a file in a folder, but having a response plan to how to deal with that and what you do to it, and what you do with the tie kickers, what you do with the bug bounty people, how do you deal with the rest of that's 90% of the challenge. So it's a difficult thing to do. Cool, any more OWASP questions before you go and hack things? Yes, hi.
How would you recommend implementing like SSRF with mobile applications?
In what sense?
Because like one might be jumping up across site, the CSRF tokens and such. But usually often you provide one like a document request, right?
CSRF and SSRF are two different things, yeah. One's tricking the server into making a request, whereas the cross-site is basically your browser will send cookies to whatever domain that you click on, which used to be a bad thing with banks because you could force transactions to be made by clicking a link. It was great. Yeah. Cool. All right. Thanks, everyone.
Thank you.